Hello everybody, how are you doing? Nice to see you today. And today we continue our work on vectors. And today I'm concerned about some very special situation about vectors. So we know now that vector is a directed sector, and we denote vector using the small letters and bar or arrow above this letter. Is a vector. Is a vector. Vector. There are some special situations. The first one is a zero vector. A zero vector A is a vector which components, all of these components of which vector are zeros. So this vector can be n-dimensional vector, so we have n zeros. Consequently, the magnitude of this vector is zero. Is zero vector. And this zero vector, usually denotation of this denotation of the zero vector is a zero and this arrow thing. Also, one very special situation is a unit vector. Unit vector u bar equal some vector. I denote here its components, so that the magnitude of unit vector is 1. Examples here. So I denote like I vector here. It has 1 as a first component and zeros. It's clear that the length of this vector or magnitude equal 1. Examples. For example, vector A equal 1 over square root of 2, 1 square root of 2, 0. So it's clear that if you try to calculate the magnitude of this vector, you'll get a unit here. How to transfer? Sometimes you have a job, an example job like job. Now you have a vector and you have to define a unit vector along the given run. This operation is known like normalization. Normalization if you have a vector A, you can transform it into unit vector which has the same director, which has the same direction as a vector A, as the A vector. It's very easy to do. Here you can see a normalization operation here. Normalization. It's very easy to do. You have just calculate with first step here. Calculate magnitude, and the second operation, you have to divide your vector or multiply your vector by unit vector. If you want to calculate the unit vector, it is the vector A multiplied by 1 over magnitude of this vector. This operation is known like normalization. Example, vector A has components 2, 3. The first step here, magnitude of this vector A bar equals square root of 2 squared plus 3 squared, and you have 4 plus 9, and it yields 1 square root of 13. And normalization, vector u equal 1 over square root of 13. We take the positive root times components of the vector, of the given vector. Since that a new vector has components 2 over square root of 13, 3 over square root of 13, and it gives your it yields the unit vector. You can check if your calculation were right or not. You can calculate, check point here, point. Let's calculate magnitude of the u vector, and it gives square root of 2 over square root of 13 square plus 3 over square root of 13 squared, and you have here 2 squared plus 3 squared over a square root of 13 squared. Finally you have 4 plus 9 over 13, 13 over 13. Since that you have 1. So obviously this vector has magnitude 1. So that's all about this short topic here. So you know now what is it unit vector, what is it normalization, and about zero vector, and that's all. So see you later. Next our topic will be dedicated to the decomposition vector into components.